Hello guys, everything okay with you? It's a pleasure to present our work at BCCM with the title Temperature Evaluation in CFRP Drilling. Me, Cristiano De Vite, and co-authors André João de Souza and Guilherme Vargas Schirmer. The application of carbon fiber reinforced polymer have grown considerably due to the need for applications with high rigidity and resistance, low weight, and good anti-corrosion properties. Subsequent processes, such as machining, make it possible to assemble the components, with drilling being necessary for the installation of rivets and screws, as well as cuts for opening according to specific size. Uh, During the machining of composite materials, some problems can be highlighted. Fast wear caused by fibers on tools, lamination, cracks, and thermal degradation of the matrix. These effects interfere with the mechanical properties of the components. The drilling of laminate composite with helical drills is susceptible to several types of defects. Defects in the entrance of the hole caused by the detachment of the fibers in the first layer of the plate by the main cutting edge of the drill, causing the lamination. Defects in the hole exit attributed to the stress caused by the thrust force in the last layers of the plate when the tension exceeds the adhesion limit between fiber and matrix. Cracks occur which propagate, causing the lamination. Dimensional effects, which are consequence of the variation of the fiber angle in the relation to the cutting edge at the moment of the shear. Fibers cut at 90 degrees undergo greater the elastic deformation, reducing the final diameter of the hole in this direction. Thermal effects originate for the friction between drill and part, uh, and affect the integrity of the polymer matrix in addition to impair the finish of the whole wall. Uh, Regarding the effects associated with the drilling temperature of CFRP, some studies have been carried out to circle this situation. Ramirez evaluated the wear cutting in CFRP drilling in order to correlate the wear with the damage of the tool. Park demonstrate that carbon fibers can weaken the binder in cobalt grains. The splinters and fractures can occur at the cutting edges of the tool. The environment agents that cause these failures: electromagnetic effects, atmospheric electrical discharge, radiation gases, and moisture absorption to the contact with the organic liquids such as lubricants used in the manufacture of some elements. In the drilling of composite materials, the use of cooling lubricant is not recommended. The absorption of liquid by material where results in a reduction in the fatigue life and the mechanical properties of the material due to the lower adhesive forces between the matrix and fiber, leading the errors in shape and precision, not only in drilling but in all material. Uh, However, the process carried out without lubricants results in higher drilling temperatures. When the maximum temperatures are observed, they are associated with greater friction between the reinforcement layer, as they are no longer cut but pressured. When low field rates are used, a greater total contact length of the drilling tool and the partner occurs with greater friction between them. justifying the use of lower feed parameters for the experiment. Dry drilling can induce geometrical errors due to the possibility of heat accumulation in the cutting zone due to absorption of lubricant coolant. In conventional drilling, due to the limited access to the cutting zone to reduce temperatures can generate a temperature above the glass transition temperature. The great test impact occurs at the exit of the holes due to high susceptibility to damage from delamination, shipping and burrs, introducing great challenges for the generation of a qualified cut for the CFRP. The temperature monitoring process, verification by contact by thermocouples and sensors are the most common. Some researchers use infrared thermography to perform this analysis due to the ability to verify a large detection area concentrated on the analysis at the drill outlet, where the characteristics of input area, cutting tool, and chips is still not better analysis. Thermogravimetric analysis allow the objective. This work aims to evaluate the temperature in CFRP drilling process and to observe defects such as thermal degradation which may compromise to use for material in their applications. Data acquisition are performed using data logger and temperature uses and the thermocouple used was type R with 0.5 with a measurement range between 0 to 1450 degrees. The drills used are helical metal carbide model H10M series coral drill with cross edging and 6 millimeters. The distance between the center of the holes was 20 millimeters. The thermogravimetric analysis for the evaluation of the thermal degradation temperature of CFRP was analyzed by Lapon. This is the drill used in the experiment, the machine, data logger, and the plate used in the tests, and the distance between the surface as the thermocouple. The cutting parameters used constant feed, 0.05 millimeters per revolution, and constant drilling speed at 60 meters per minute. The CFRP plate is made up of sheets manufactured with prepreg carbon fiber fabric having 10 layers totaling 2.4 millimeters. In this experiment, the temperature of the drill was not measured because the experimental apparatus is not appropriate. The drill with 6 millimeters plate of CFRP, thermocouple at the entrance of the holes, and the thermocouple at the exit of the holes. Temperature measurement can be in the figure 2. For the measurement point of the hole 1, with the distance 0.8 millimeters from the thermocouple in relation to surface of the hole, maximum temperature of 35.2. In the hole 2, the distance between the hole surface and the thermocouple is 0.9 millimeters, reaching maximum 35.9 degrees. In the hole 3, the distance between the hole surface and the thermocouple is 1 millimeter, reaching maximum 35.7 temperature. For the hole 4, the distance of 0.5 millimeters and the the surface of the hole, the thermocouple reached 49.2 degrees. In the hole 5, the temperature is measured in the entrance of the hole with a distance between the surface of the hole and the thermocouple of 0.5 millimeters. The maximum temperature was 44.9 degrees. Being lower compared of the temperature of hole 4 at the outlet, being smaller compared to the observed by Fu, who observed temperatures close to 200 degrees. Highlighting this point is essential in the monitoring and of the region. This can associate with the trial used as well as the monitoring system by infrared, which can obtain the values instantly in the region of the output. The temperatures at the entrance of the hole are below the temperature observed by both experiments carried with drills of larger diameter and faster cutting speeds, causing greater friction between the drill and the surface. The thermogravimetric analysis and those derived from the thermogravimetric curves obtained from the CFRP observed the temperature reduction for approximately 340 degrees of the sample reaching the peak of degradation in the range of 450 degrees. The results were close in the TIJA values obtained by Turkey, who analyzed the TIJA of the CFRP and observing the impact of the temperature in the ultrasonic assisted drilling process. In the experiment, the ultra compared to temperature reached by the conventional drilling process, about 19.1 degrees, lower than the start of degradation of CFRP. The evaluation of matrix degradation can be seen in the figure 4, where the interface between layers is observed. In these images, there are no degradations of the matrix at the temperature that reached the process. Only the surface is observed without deformations that could indicate a displacement of the fiber. This indicates that there was no removal of the fibers from the matrix, with maintaining the integrity. In the experiments carried out by Ben, up to the temperature range of 208 degrees, the same characteristic was observed. Only when reaching temperatures above 306 did the matrix be removed. The most of the fibers remained on the machine surface. The author identified this change in failure mode to the increase in temperature the bond between matrix and fiber was easier to be broken. Another factor indicated by the author is the decrease in the friction coefficient between fiber and the matrix. The following conclusions are observed from the temperature analysis in the drilling process of CFRP. CFRP thermogravimetric analysis identified degradation temperature above the temperature observed in the drilling process. Say analysis of CFRP did not observe fiber deformations and matrix degradation. For the two, no defects or wear were observed. Only the adhesion of particles of the polymeric matrix occurred. The drilling temperatures were lower than the degradation temperatures of the CFRP matrix. The drill has no defects or deformations at the cutting edge. The reference used in that work and the acknowledgements to collaborate of this work. Thank you very much.